Everyone. The GCSE maths topic we're going to be looking at today is the law, or the laws, rather, of indices. Now, you may have seen these in your book and found them quite daunting as a long list of rules that you have to memorize and know for your exams. And we're here to show that it doesn't have to be that way, that we can build up these rules from very simple examples and start to see them as logical steps that build on each other rather than just a long list of rules that you have to learn. In this lesson, to avoid any confusion, we're only going to be focusing on the rules that have whole numbers as powers, that is, including zero and negative numbers. And we'll start with what a power or an index actually is. A power is a number we call the base raised to another number that we call the power or the exponent. A to the power of b reads as a to the b power. Let's use real numbers to make that clearer. 2 to the power of 3 is 2 times 2 times 2. 2 multiplied by itself 3 times. And that's 8. Not to be confused with 2 times 3, which is very different. Let's try another example. 3 to the power of 2, or 3 squared, as it's commonly called, is 3 multiplied by itself twice and gives us 9. What if we have to combine these with multiplication? If we have 2 to the power of 3 times 2 to the power of 2, and we're asked to evaluate this, meaning give it a value, a number, we could start by finding 2 to the power of 3, which is 2 times 2 times 2, and finding out what 2 to the power of 2 is. 2 to the power of 3 is 8. 2 to the power of 2 is 4. And our answer is 32. But is there a quicker way that we could have gotten there? Well, how many 2's do we have when we write this out the long way? We have 5 of them. 2 multiplied by itself 5 times is 2 to the power of 5. And that's our first rule. A to the m times a to the n is a to the m plus n. 2 to the power of 4 times 2 to the power of 2 is 2 to the power of 4 plus 2, which is, 2 to the power of 6. And if you were to multiply that out, it would equal 64. What about division? Let's take 2 powers and divide them. 3 cubed divided by 3 squared. Again, we could do this the long way. We could do 3 times 3 times 3 divided by 3 times 3. 3 times 3 is 9. 9 times 3 is 27. In the denominator, 3 times 3 is 9. And that gives us 3. Well, 3 is the same as 3 to the 1, because when you subtract the powers, that's what we get. When you divide, we do 3 to the 3 minus 2, which is 3 to the 1, which is just equal to 3. That gives us 2 new rules. One is that when you divide 2 powers with the same base, you subtract their exponents. And the second is that anything to the power of 1 is just the number itself. A to the 1 is a. 3 to the 1 is 3. What if we were to do a power raised to another power? 2 cubed squared, or raised to the power of 2. Well, anything to the power of 2 is that number multiplied by itself. And we have a rule for this. When we multiply powers, we add their exponents. That gives us 2 to the 3 plus 3, which is 2 to the 6. But could we have gotten there quicker? 6 is just 3 times 2. So when you raise a power, a to the m, to another power, n, you multiply those powers together, a to the m times n. Let's look at another example. 2 to the power of 3 raised to the power of 3. That would be 2 cubed times 2 cubed times 2 cubed. And the rule doesn't have to have just 2 powers. You still add all of these powers together, or these exponents together. It gives us 2 to the 9, which is just 3 times 3. Let's recap the rules that we've learned so far. We know that when we have a to the m times a to the n, we add the exponents. When we have a to the m divided by a to the n, we subtract the exponents. When we have anything to the power of 1, that is just the number itself. And we know that when we raise a power to another power, we multiply the exponents. What if there's more than one term in the brackets when we do that? What if instead of a to the m raised to the power of n, we have a to the b raised to the power of 3? Well, that's ab times ab times ab. How many a's is that? 3. So we have a cubed, and we have the same number of b's, b cubed. So our next rule is ab to the n is a to the n times b to the n. Now we're going to explore what happens when the powers are 0 and negative exponents. And we can work out those rules simply by extending the ideas that we've looked at already. Imagine that you have 3 to the power of 2, and you divide that by 3 to the power of 2 by itself. According to our rules, when you divide 2 powers, you subtract their exponents. So our answer would be 3 to the 0. If we work this out the long way, 3 times 3 over 3 times 3, that's 9 over 9, which is 1. So 3 to the 0 is 1. In fact, anything raised to the power of 0 is always 1. Let's look at this another way. Let's start with powers that we're comfortable with, and we're going to steadily work our way down to powers that we're unfamiliar with. Maybe 2 to the 1, 2 to the 0, 2 to the negative 1, and 2 to the negative 2. 2 to the 4 is 2 times 2 times 2 times 2, which is 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1, well, as we were going down, we were dividing by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. So 4 divided by 2 should just be 2. A to the 1 is just a. If we continue, we divide by 2 again. 2 divided by 2 is 1. So anything to the power of 0 is 1. Let's look at what happens if we continue that pattern into the negatives. 1 divided by 2 is 1 over 2. 2 to the negative 2, we just continue dividing by 2. That's 1 over 4. So 2 to the negative 1 is 1 over 2. And 2 is the same as 2 to the positive 1. And 2 to the negative 2 is 1 over 4, where 4 is the same as 2 squared. Do you notice the pattern? A to the minus n is 1 over a to the positive n. When we have a negative exponent, we take what we call the reciprocal of the number. That's 1 over the number. And the power becomes positive. So 2 to the negative 2 is 1 over 2 to the positive 2. And that's 1 over 4. Interestingly, this also works the other way. If you have 1 over 2 to the power of 3, or 2 to the power of negative 3, and you're asked to solve this, well, that means that this is the same as 2 to the positive 3, which is 8, the reverse of the rule that we just looked at. So when there's a negative exponent in the numerator, you can send it to the denominator and make it positive. Or when there's a negative exponent in the denominator, you can actually send it to the numerator and make it positive. Let's look at one more rule, and that is when we take a fraction, 3 over 2, and we raise it to a power. Well, we know that 3 over 2 to the power of 2 is 3 over 2 times 3 over 2. 3 times 3 is 3 squared, and 2 times 2 is 2 squared. So what happened? The power was distributed to each of the numbers, and that's 9 over 4. So the rule tells us that a over b to the n is a to the n over b to the n. Thank you for joining us during this lesson, and I look forward to seeing you next time.